area of parallelogram if two side vectors of triangle are given. Okay, vector, say that this is vector B, this is vector A given. Okay, the area of the triangle ADB, so that region, okay, is equal to 1/2 half modulus vector A times modulus vector B sine theta. Theta is between the two vectors. Okay, sine theta. So this one, okay, remember the formula. Modulus vector A cross vector B is equal to modulus vector A modulus vector B sine theta. So this one replace to modulus A cross vector B. Okay. And that one is area of the triangle ABD. So area for all the area for parallelogram means that times 2. Parallelogram A, B, C, D. Okay, so 2 times the area ABD times 2 means that this is the area for the parallelogram ABCD. Example 3. Given vector P to I minus J plus 3K and vector Q equals I minus J plus 2K, find unit vector which is head, okay, which are perpendicular to P and Q. Okay, so say that this is vector P, vector Q. Okay, you need to find a unit vector which are perpendicular to P and to Q. This one actually to find the vector which is perpendicular, you need to do cross product. Means that vector P cross vector Q. This is the vector which is perpendicular to vector P and vector Q. Get a unit vector. Find this one first and find the modulus of vector P cross vector Q and find a unit vector. Or I can write like this. A unit vector P vector Q is equal to vector P cross vector Q over modulus vector P cross vector Q. Okay. And B, the angle between P and Q. Angle between P and Q. Okay. Actually, you have two formula. You can use formula A, vector A dot vector B equals modulus vector A times modulus vector B cross theta. Cos theta. Or change to P, Q, P, Q, cos theta. Or you can use formula, okay, modulus vector A cross vector B equals modulus vector A, modulus vector B, sine theta. Or change to P, Q, the P, vector Q, sine theta. Okay, so we discuss example 3. So a unit vector perpendicular to P, vector P and vector Q, okay, equals plus minus vector P cross Q over modulus vector P cross vector Q. So to find vector P cross vector Q, you need to do determinant. First row always I, J, K. The second row is write out the component to I, J, K for P. The third row is component I, J, K for Q with the Q. Okay, and then find the minor, and then lastly you get a vector. Cross product produce a vector. I minus J minus K. Okay. Next step, find the modulus vector P cross vector Q. To find the modulus is square root of every component, square every component, and that's 3. So a unique vector, okay, vector n is equal to vector P cross vector Q, okay, is equal to, okay, all the result from the cross product I minus j minus k over modulus, the modulus. Okay, this is that one. Okay, vector n has negative positive sign because vectors in both directions are perpendicular to P and Q. Okay, this is vector P, vector Q. Theta is angle between vector P. Okay, theta is not, okay, is not 90 degree. Okay, not always 90 degree. Okay, and the where we find the cross product between P and Q, this is n. Yeah, vector n. Vector n is perpendicular to P, vector Q. Go up or go down. This is n. That's why it has negative positive sign. Okay. Let theta be the angle between vector P and vector Q. Okay, we use this formula. A dot B was modulus A, modulus B cos theta. Okay, and find P dot Q. Still remember to find P dot Q. Okay, use the matrix form, and the result is 9. Okay, and find modulus vector P. Substitute, and answer is 14. And modulus vector Q. Substitute all the components. Answer is 6. Substitute in the formula and find theta is equal to 10.989 degree. Okay, make sure you know how to find the dot product. Okay, how to find modulus between the two vectors. Okay, example 4. Given A, coordinate A is 3 to -1, B -1, -1, 2, and C 1, -3, 2. Find a vector which is perpendicular to vector AB and vector AC. Okay, let's say point A, B, and C. Vector AB is from A to B. This is vector AB. Vector AC from A to C, and this is vector AC. Okay, so a vector which is perpendicular to this vector means that a vector, okay, this vector, I call this one N, vector N, perpendicular to vector AB and perpendicular to vector AC. Okay. To find this vector, you need to do cross product. Cross product between these two vectors. Vector A, vector AB, vector AC. Okay, AB. Okay, point out. This is also point out. Okay, means that point out, out. Okay, if point in. So this is theta. Theta between these two vectors. Okay, so now we need to do a cross product. Okay, before do cross product, you need to find vector AB, vector AC. Before find vector AB, vector AC, you need to change the from coordinate to vector form. Okay. Okay, and next step still got question here. The position vector of a point D in which ABCD is a parallelogram. Hence, find the area of this parallelogram. Means that D here. Okay, D. So, vector AB is parallel to CD. AB parallel to vector CD. And at the same time, vector AC is parallel to vector BD. Okay, you need to find this position vector. Okay, then find all the area for all parallelogram. Okay, so means that from the coordinate given, change to position vector. Okay. Okay, to find vector AB, okay, A vector AB, AO, vector AO plus OB. Okay, or negative OA, vector OA plus, okay, OB. This is position vector. Or can find like this. Or vector B minus vector A. Or vector B minus vector A. Okay, this is small b, okay, curly line, okay, to show that this is position vector. Or you can write OB, OB, OB up, the arrow up, okay. And this is OA, okay. Then, from the given coordinate, okay, change to position vector. Vector, this is component I, J, K. Okay, for vector A, 3I plus 2J minus K. Vector B, negative I minus J plus 2K. Okay, should write curly line below the component I, J, K. So, component I minus component I, negative 4I. Component J minus component J, get negative 3J. Component K minus negative K, get positive 3K. This is vector AB. Then find vector AC, do the same thing, and get, this is the answer, still in vector. After you get vector, you need to find, to do cross product. Okay, cross product. Okay. Okay, make sure to do cross product, you need to do in determinant form. Okay, the first row should be IJK, component IJK. This is the second row, and this is the third row. Find and get 6I plus 6J plus 14K. Okay, and then find the area of ABC. Area of ABC, the formula is half magnitude vector A cross vector B. Find the magnitude. Okay, 6 squared plus 6 squared plus 14 squared, and get is 2 times 67. Then substitute into formula and get the answer. Area for the triangle ABC is equal to 67 unit squared. Settle for the first part. Okay, and to find vector, to find D, okay, position vector D, okay, we know that vector AB is parallel to vector DC. AB is parallel to DC. Okay, because of the same magnitude, okay, you can write this one in this form. Okay, because of the same magnitude, we can say that lambda is equal to 1. Or vector AB is equal to DC. Okay, from the given equation, okay, vector DC is equal to OC, vector C minus vector D. Okay, vector OC OC, okay, minus OD is equal to vector AB. DC is equal to AB. Okay, just take one. That's the statement. Okay, DC equals AB. Okay, and OD, you want this one, OD, okay, is equal to OC, okay, OC, this, okay, take this statement, OD is equal to OC, vector OC minus vector AB, okay, OD is equal to OC minus vector O minus vector AB. Okay, and then OC, position vector OC is equal to I minus 3J plus 2K minus this is vector AB. Then answer is 5I minus K. This is position vector. Okay, and to find area of the parallelogram ABC, means that there is actually twice. Oh, here, before this, you find ABC, right? Times 2. Times 2. And answer is 2 times 67. Okay, 2 67 unit square. Exercise 1. Given vector B equals 3I plus 2J minus K, vector C, I minus 4J plus 2K, A dot B, vector A dot vector B is equal to 5, vector A dot vector C is equal to 4. Find vector A cross vector B cross vector C. This is using property. Okay, using property, this property. Okay, and okay, using property. Okay, property. Okay, write the property here. You need to remember the property. Okay, and substitute. Okay, A dot C is equal to 4. Okay, vector B given. Vector B given. Okay, 4 is constant. Okay, scalar. Okay, and times vector B minus A dot B given 5. Vector C given. Okay, so expand. Answer is a vector. This one you need to remember the property. Okay. Exercise 2. Given vector U is 8I minus 2J plus 5K, vector V equals negative 4I plus J plus lambda alpha K. By using the vector product, determine the value of alpha if vector U is parallel to vector V. Vector U parallel to vector V. Parallel, same direction or opposite direction. Theta equals 0 or 180. Okay. To show that parallel, okay, use this statement, the equation. Vector U cross vector V is equal to 0. To show, or not to show, this is to find the value. So we need to use the statement, the equation, vector U cross vector V equals 0. Then using the determinant, using the determinant, okay, and the first row IJK, this one the second row, the third row, find, expand the determinant, and that one is equal to 0. Why 0? Because of to show that vector U parallel to vector V. Okay, to show that vector U is parallel to vector V. Okay. And then, okay, compare the component I. Component I, Okay, negative 2 alpha minus 5 is equal to 0 because that one is equal to 0. 0I plus 0J plus 0K. And then get alpha is equal to negative 5 over 2. Okay, do the same thing. Okay, just for checking. Okay. Okay, if you want to check, do the same thing for component J. But it's okay, just one is okay. But say if you have time, you want to check alpha, do the same thing. Is equal to 0. 8 alpha is equal to negative 20. Therefore, alpha is equal to negative 5 over 2. Done. Settle.